Hello and welcome to the LandKit Topo Workflow, where we'll be learning about how to create and modify our topography using LandKit's topo modeling tools. This is a new workflow that's better than ever with a range of new functions and features that you're going to see throughout this video. Now you'll notice that we have Grasshopper minimized down here in the corner, and although these tools were developed using Grasshopper, we've created this lovely workflow panel as well as a template of layers in our Rhino file to allow us to utilize these topographic tools without having to understand Grasshopper. LandKit uses what's called a fluid digital model approach. This allows you to quickly iterate through design ideas while visualizing, understanding, and responding to the changes that you're making in both 2D and 3D. Simple geometric inputs can modify the topography and the contours directly, or can be utilized to create features that will grade your topography, such as walls, using curves and spot elevations, stairs, which utilize a surface in 3D space, paths, which will grade your topography at a specific slope using a center line and a starting elevation, and curbs, which utilize the same inputs as walls but also allow you to create fully customizable curb cuts. Let's talk a little bit about our layers and panel and how they come together. We've set up this workflow template with a specific layer structure and naming convention in order to feed the geometry from these layers directly into the Grasshopper script to be interpreted by the LandKit components. That way, all you need to know is how to organize and create geometry on the appropriate layers in order to grade your topography in particular ways. We do this by adding and manipulating geometry on the existing and proposed sublayers. In this case, we have a set of 3 sublayers: the topography, features, and mods layers. Under the topography layers, we have a series of layers that we refer to as the Geoset. Anytime we make changes or add or take away geometry from these layers, we're going to have to refresh the Geoset in order to see those changes happen. This is done using the Refresh Geoset button on the workflow panel here. So if I wanted to change this depression that's helping collect water into a drain in the middle of this plaza to a mound, I could modify this breakline up, and you'll notice that there's no changes happening until I hit Refresh Geoset. Once I do that, I can see that mound appear in the middle of my plaza. If I want to undo that action, I can go back and see that, again, the topography is not going to change until I hit the Refresh Geoset button. This is the case for all geometry on these layers under the topography layer. The features will update automatically, and this is something that you saw in the beginning when I was moving around the spot elevations for the top back of my wall, or the bottom front of my wall, in this case. We also have a specific setup for how the geometry is organized for the different types of features, where we have different types of geometry for walls, stairs, paths, and curbs. And those geometries will affect and create and modify the landscape in the ways that curbs, paths, stairs, and walls do. The last is mods, which is one of the first ways that you saw me manipulating the topography, where you have different types of geometry that grade or sculpt the topography that will update automatically. In this case, a piece of 3-dimensional geometry that is creating a mound or a depression. All right, now that we know how to organize geometry in the appropriate layers to create the different grading tools we're using in our landscape, let's talk a little bit about how to control the detail of these features and mods using the parameters in our workflow panel. So you'll notice that when you open up the workflow panel, you'll begin on the Info tab, which gives you some information about how to utilize this workflow panel. And then the next 2 tabs are the Existing and Proposed tab, which allows us to control the parameters of the existing features and mods and proposed features and mods. So if we want to change how this, let's say this proposed path is being represented in the landscape, we can navigate over to the proposed features and see that we have some path parameters that we can expand. So here, to begin, let's start by toggling on the preview of the path so we can see the path beginning at the starting elevation that we've placed in the appropriate layer. We've also placed the center line in an appropriate layer to indicate how long we want this path to be. And then over here, we've indicated a width that we want the path to be, as well as a slope that we want this path to grade up the hillside. So if we want to change the width of the path, all we have to do is, using these sliders here, we can double click the little gray tab and enter in an exact value that we want. In this case, I want to make this path a little bit less wide, so I'm going to decrease it down to a 2-foot wide path. You'll see that it will immediately change the width of the path, and regrade the site accordingly. So now, because of a slightly less wide path, our path grading is terminating at a slightly lower elevation than it was before. So what we can do here now is we can head over to our path slope percentage and double click that and increase it up to, let's say, 6 in order to create a slightly steeper path that will terminate at a higher elevation that meets our stairs. So now that we have that path set at an appropriate elevation for where we want it to terminate, let's look at some of our other features and how we can control and manipulate them. So under our curb and wall parameters, we have a set of tolerances that we can control, as well as the ability to toggle on and off wall tops. So the wall tops allows us to implement a spot elevation on the front of our wall in plan view aligned with the front of our wall. And with that single spot elevation, we can control the height of the wall above the grading that's taking place. We can also change the elevation along that wall top by adding in more spot elevations and adjusting their height so that the wall can lower and rise according to how high we want it to be above the grading at different locations. Additionally, we have tolerances that allow us to control how these wall curves and spot elevations relate to each other. So in plan view, we have a front bottom of wall curve and a top back of wall curve. And how these two relate to each other is controlled by the curve tolerance. So the 2-foot curve tolerance, which is the default value, is saying that it's going to search the center point of each of these curves, and if the center point of these curves are within 2 feet of each other, then these two curves will relate to each other to create a wall. Additionally, the spot tolerances will adjust how close these spot elevations for the top back of wall and bottom front of wall need to be in plan view to the wall curves in order to relate to them. So if I were to take this spot elevation and move it more than 0.4 feet away from the wall, it's no longer going to apply to the wall and actually create grading for it. So if I were to move, let's say, this spot elevation further away from the wall, it's going to adjust the wall and grade from this spot elevation to this spot elevation at a continuous slope. So if I move that back closer to the wall within 0.4 feet, it will now process within the wall and create the grading spot elevation for that wall where I have it. The same works for the curb parameters. You have the same tolerance for the curb parameters, although you also have a series of control over the curb cuts. So the ability to adjust the curb cut width, run, and flare to create fully customizable curb cuts. Additionally, the stair parameters allow you to control these step risers, which will affect how high the stairs are and then also affect how many stairs we're dealing with. So you can see we have a little bit of a preview here for the run of the steps, which will change depending on the step riser value. So if I increase the step riser to 7 inches, you'll see that we have a much wider run to accommodate that change in elevation. The last set of parameters that we can control in the proposed and existing are the mods. And these allow us to change how these different mounds or sculpting depressions or mounds are being generated in the landscape. And it allows us to control the smoothing of the landscape. So you can see how these mounds have a smoothness to them and a lot more detail to them. And that's by using the smoothing parameters here. So under proposed mods, you can see that we have a couple different sets of mods. We have the first tier mods and the second tier mods. And if we look at the mods layers, you can see that we have a first tier mods and a second tier mods that are named accordingly. So the smoothing, grading, and sculpting, and the smoothing 2, grade 2, and sculpt 2 here that we have available to us. So if we are to change the smoothing parameters, we can change the point spacing here from 0.5 up to 1 and see that the detail of these mounds is decreasing. That means we're generating fewer points for creating these mounds, these sort of organic looking mounds. Additionally, if we were to decrease it down to 0.5 or lower than 0.5, we're going to get greater detail, but that means it's also producing more information that will increase the processing time. So balancing the processing time with the level of detail is something to pay attention to. Additionally, you'll see that with with each type of geometry that we're placing in the landscape, whether that's a grading geometry or a sculpting geometry, we can affect how these are generating as well. So the slopes of these hillsides can also be affected. If we wanted to increase the slope from 50% up to, let's say, 80%, we type in a value of 80 and you'll see that the slopes of these hillsides are a lot steeper. And those values are being maintained regardless of how we're moving around the geometry. So if I drop this into a depression and create this sort of nice mound being transformed into a depression, we can see that the slopes of the hillsides from the existing elevations down to where this geometry is being placed in the site are being maintained. And so if we were to increase that up to, let's say, 90, we're going to get even steeper hillsides regardless of whether or not this geometry is creating mounds or depressions. We can also change the way the top of the mounds are being represented. Currently, we have these sort of flat paths that are being generated across the tops of the mounds. But if we want them to be a little bit more like ridge lines, we can decrease that value down and create a sharper ridge line along that edge. So the ability to actually control the offset from that geometry before it starts grading is something that you need to pay attention to as well. So I'm going to decrease this offset back up to 1.5 and decrease the slope back down to 50% slope, so we're getting nice steady mounds. In addition to pushing and pulling the landscape using the grading tools, which utilize 3D geometry, we can utilize the sculpting tools, which affect the site using 2D geometry. So in this case, these existing condition swales that we're creating next to this path can be affected and changed into mounds. So if we head over to the existing tab and the mods tab underneath of that, we can see that we are creating swales here with a 0.4 depth along them. So you can see that depth being created here. And if we turn on the existing conditions geometry, we can even see the curves that we have aligned in plan view with those swales to push and pull the landscape. So now what we can do is we can change this value from negative 0.4 up to, let's say, 1, and we can see these swales now turning into mounds that again are just grading the site at the elevation that we've assigned with a specific spread. So you can think about the height as the rise and the spread as the run. So if I increase this up to, let's say, 1.5, you'll see that the width of the mounds increases, which decreases the steepness of the slope. And then we also have an offset too, which works the same as the offset for the grading tools. So the ability to control and manipulate the site in different ways using the grading and sculpting tools can be quite helpful depending on what you're trying to create. Let's talk a little bit about some of the other ways that we can manipulate our landscape using the workflow panel. Here at the very top of the workflow panel, you'll notice that we have two toggles and a button. The Refresh Geoset button is something we've already spoken about in relation to the topography layers here and all the geometry that goes inside of them and how we refresh and update the topography based on the moves we're making in those layers. The top left-hand toggle, as you can see by the tooltip, is the play pause button. This allows us to freeze the entire Grasshopper script, which could be useful if you're trying to halt the processing for making a lot of moves with your features or your modifications. The other toggle up here is the proposed topo toggle. This allows us to toggle between previewing the existing conditions, as you can see here, and the proposed conditions integrated into the existing conditions. So if we turn on the existing geometry, and we can actually see how that existing topography is being created by the break lines, the path, and the curbs that we have implemented here in the existing conditions. Now once we toggle on the proposed, we can see how the proposed geometry is being implemented only within the boundary that we've created in plan view for where we want to add the proposed design. This will seamlessly integrate into the existing conditions. You can have as many of these boundaries as you want. It's just important to remember that you create that boundary in plan view where you want your changes to be made, and that all of your proposed geometry exists within that boundary. Let's head over to the Out tab now and scroll down to see our site size selections. You'll notice that we have a range of different options with recommendations for how large of a site that these apply to. And a good way to think about these is in two different ways. One is the size of the site that you're working on directly and the resolution that you're going to get as a result of that. But the other way to think about it is the amount of processing time that it will take to use the smaller or larger site sizes. So if you think about a small site size as a higher resolution image of your site, a larger size will be a lower resolution of your site. So you can see here a lot of detail in what I'm producing in terms of the grading moves that I'm making. But if I were to change my site size to a medium site size, you'll notice that the level of detail decreases a little bit. We're getting a bit more interpolation across the features, a little bit less detail in the paths and even the curb cuts and some of the break lines and grading that's happening. So utilizing the site size is a decision about how much power your computer has versus the site size. And oftentimes we recommend people working at a slightly larger site size, like maybe a medium site size. And then when they're ready to see a lot more detail, you can drop that down to a small or an extra small site size and hit the bake button to get out your geometry that you'd like to at a higher resolution. As we move our way up from the bottom of the Out tab, there's a couple of different analysis options and preview options we have available to us. The first and most simple of those analysis and preview options is the contours, something that we were baking out before and that we have the ability to toggle on and off and even control the spacing of. So if we're dealing with a much larger site and we want to see, 5-foot contours or 2-foot contours or even 1-foot contours, we have the ability to see that. But we can also go down to much more detailed contouring in order to see some of that micro grading that we're dealing with. Some of the really basic and straightforward topo analysis preview options include being able to toggle off your mesh, preview the mesh as sort of a translucent gray topographic mesh. We have the ability to utilize a site image where we have a image that we can implement on a surface in the Rhino file, and when we overlay that underneath of our topography, it will project it up onto the topography so that we can see what that looks like. This can be quite useful for just trying to preview maybe some aerial imagery on our site, or maybe we have a sketch design from a colleague or that we did by hand that we want to overlay on the site to begin sketching out, or different ideas, or even implementing some sort of material areas plan. The other simple and straightforward ones include elevation, which allows us to see the different heights on our site in terms of a color gradient, so the darker colors being the lowest points on our site and the whitest points being the higher points on our site. We have the ability to preview slope analysis, where we can see the different slope ranges on our site, again, live while we're working. All of this is responding live to the changes that we're making. So if I wanted to recreate this mound in the middle of our plaza here, and I want to create a relatively steep mound that meets back at the edge of the wall and the other elements on our site, I can raise that break line up, hit refresh Geoset, and what you're going to see is the mound create and the slope analysis immediately generate results from that. And we even have a legend over here that's being produced by a rectangle that we can draw and place anywhere on the site. All right, let's take a look at our cut fill topo analysis preview option. When we select this option, you'll notice a few settings appear here in the workflow panel, as well as our cut volumes and fill volumes represented in cubic feet. These will be updating live as we make changes to our grading. The mesh representation is showing the grays as the cut and the browns and oranges as our fill. We can even change the level of quality of our analysis and preview by adjusting the cell size. A lower cell size will produce more points of analysis and increase the resolution, and a higher cell size will lower the resolution by spacing out the points of analysis. Our viz depth will allow us to change the highs and the lows of the gradients to match the level of cut and fill that we're producing. So if we're only cutting or filling on our site up to 4 feet, we can adjust this down to 5 to show a slightly darker gray or slightly darker orange or brown to be represented as our cut and fill. We also have a drop-down menu here that allows us to change the colors of our cut fill volumes. So if we want to see our cut in red and our fill in green, or change those colors to whatever we want, we can do so here. All right, let's look at our areas in our topo analysis preview options. When we select this option, you'll notice immediately that our material areas of our site are being projected to our 3D topography, and that those material areas are also responding to the changes that we make to our topography. So every move that we make in the grading on our site is going to be affecting the actual topography itself, as well as the material areas that are being projected to that topography. The way that we're actually creating these material areas is by organizing closed curves or surfaces into sublayers beneath the areas layer. You'll notice that we have a few already outlined here with colors assigned to them, and you can create as many of these as you want and create whatever colors you want as well, or even modify the ones that are existing here. The coolest part about the way that we're dealing with areas is that we are using what's called the collage tool. This allows us to, instead of having to trim out these different surfaces from each other to create the different material areas for our site, we can actually elevate these different curves and surfaces in 3D space so that what we see in plan view is what we get. So for instance, if we wanted this concrete path here to disappear and only have lawn between the mound and the depression that we have at the top of our hillside here, we can grab this concrete curve, which is elevated above our overarching lawn curve here, and we can move this material element down below the lawn and see that it now disappears. So if we want to bring that back, we can just elevate it back up. And we can even modify this curve and how it's cutting out from that lawn layer to create a very custom shape without having to retrim the overall underlying lawn shape as well. So if we want this to be a little bit tighter together, we can simply move these curves around, and it's going to automatically smash these curves together and these surfaces together and trim them out from each other for us. Now, if we look over here in our workflow panel, you'll see that we have a few options available to us to affect how these areas are representing or other aspects of the areas that we can utilize for construction documentation or analysis or cost estimation. We have up here our baked hatches button, which allows us to bake out all of our 2D representation. So now we can have our 2D and 3D representations of our material areas being generated just from this layering of closed curves and surfaces. We can also toggle on and off our collage tool in case we want to use a more traditional method of generating the material areas. We have this toggle for viewing the material surface area square footage. We also have the ability to produce line work as an output from the collaged areas. When baked, these will produce no duplicate line work and will be sorted by layer according to a few optional styles. The last thing that we want to mention about the areas is the ability to bake them into your file. The great part about our Bake Topo Contours and Bake Features button is that they're going to bake whatever topo analysis preview option you have selected. So when we had our mesh selected before and we clicked the bake button, we were going to be baking out a full continuous mesh of our site. In this case, if we have our areas turned on, when we hit the Bake Topo Contours button and the Bake Features, it's going to bake that information into the materials layer. Just like we had the features already being baked into this layer, now we have each of our different materials, our lawns, our swales, our asphalt and white lines and concrete and plaza, are being baked into their respective layers according to how we had them organized and categorized in the areas layers. So now we can take this geometry that is very neatly organized and touching each other and seamlessly integrated from existing and proposed, and we can export that for rendering purposes or other further types of analysis. Another useful part of the design process is being able to understand the site through section and even being able to produce sections as drawings and outputs. So if you scroll down in your workflow panel in the Out tab, you'll see that we have a toggle for section cuts. When we toggle that on, you'll automatically see a few section cuts appear up here above your site. And if we look in plan view, you can actually see the notations for where the section lines are versus the section cuts and their relationship. And over here in our layers in our Rhino file, you'll see that we have a section lines option, and any lines that go within the section lines layer are going to produce a section cut. So if we copy these around and create multiples, we can create as many section cuts as we'd like to, and we can even angle them in unique ways or shorten them down to create unique details of our site as well. We also have a starting point here that allows us to shift these section cuts represented up here in plan view around so that we can have them a little bit closer to our site. And the wonderful part about the section cuts is, just like everything else with these models, they are producing a live result. So every change that we make to the site is going to be reflected in the section cuts. Just as we move the section cut around, we're seeing the change happen. If we were to grab a mound or a depression and change it, it's going to change the representation in the section cut as well. The last thing that you can do here is include or disclude features and even bake the sections into the file to produce actual line work that you can export to another software in order to generate section perspectives or even just section details. Next, let's take a look at some of the big features that we've added to the Topo workflow. The first of these is the carbon calculator tool. When we toggle this on in the Topo analysis preview options, we're going to get a plan view of the different materials that we are applying to our site. We're also going to get a graph that appears in plan view, as well as some calculations of the different carbon outputs of our materials that we're applying to our site. So as we change these around and move these using our areas in our areas layer, for instance, changing this concrete path to a lawn now, we can see how it's going to change the values and outputs of the carbon on our site. Now, the graph allows us to see a sort of baseline represented in red of 0 carbon output, and where each of these different materials are in relation to that output. So overall, our white line represented down here is showing that our net carbon output over the span of 60 years is nowhere close to crossing that 0 baseline for carbon output. And so that would cue us into maybe shifting some of these different materials to different types of materials, or perhaps using slightly more carbon-friendly materials on our site. Doing the path here in lawn versus concrete is one way to do that, but we can also think about the way that these materials are installed and repaired over their lifespan. So using Sasaki's Carbon Conscious database, researched by Chris Hardy, we've integrated materials from that database into the materials that we have on our areas layers. So if we want to create a new material or change some of these to a different type of material, we can create a new material and maybe call it path, and we can give it a color. In this case, we're just going to give it a orange color, and we can take this path and we can assign it to that layer. When we change it to that layer, this graph and the calculations are not going to work because we haven't assigned a material to that layer. So when we toggle on the assign land use areas down here, it's going to bring up a pop-up that shows us in blue the materials that have assigned materials from that database, and the orange or yellow highlighted materials from the areas layer indicate that we need to assign some sort of value to them. So when we select that, we can drop down this menu here and see all the different materials that have been researched as a part of that database that include their installation carbon output, the carbon sequestration or releasing over their lifespan, as well as the carbon cost of replacing or repairing that particular material. So if we're going to go down here and choose a path material that we like, perhaps we want to use some sort of clay brick hardscape, and we can choose a specific one that matches the way that we're planning on installing that. So I'm going to select this first one here, and I'm going to hit done. And then once we have all of our materials assigned, we can hit done again, and it's going to recalculate those values based on that new material or any changes to the materials that we've made. So now this path material here is calculating the area, square footage of that material, and then assigning that carbon value from that database and research to that square footage and giving us this output over the span of 60 years. In general, the negative numbers can be thought of as bad, or the embodied carbon of that material, and the positive numbers can be thought of as good, or the sequestered carbon of that material. We definitely recommend that you use this as a way to estimate or gain an understanding of which materials are really producing high outputs of carbon over that lifespan versus being able to sequester over the lifespan of that particular material, rather than using these as solid numbers. And we still recommend people going and applying their materials and their sites into a online database like the Carbon Conscious database, which is constantly being updated more frequently than the instilled database here. The next great feature that we've added to the Topo workflow is the water flow analysis. If we go over to the workflow panel and scroll down to the bottom of the Out tab, you'll see that we have a toggle for previewing water analysis. When we toggle this on, you'll be familiar with a few of the toggles and settings related to the water flow lines, which were available in the previous version of the Topo workflow. This allows us to preview where water is flowing from and to, and where it's collecting or stopping its movement. We can also see the water flow respond to changes that we make in the landscape. So if we were to switch this mound to a basin, we can see water now flowing into this basin as opposed to away from it. So it gives us a lot of the ability to see where water is moving and respond to that while we're making our design decisions. We also have flow line settings, which allow us to control how many different flow lines are appearing on our site, as well as the step size, which allows us to adjust for the site size or the processing power of our computer. Just below the water flow line settings, we have a drop-down menu for different types of water analysis. The upslope area, the first selection, allows us to calculate how much water is flowing from an upslope area in each location on our site. More upslope areas flowing to that location are indicated in darker blues, and less upslope areas flowing to that location are indicated in white or lighter color blues. The flow intensity, the next selection, allows us to see a map of where flow lines are conglomerating in greater density. So areas where there is water pooling into specific zones or collecting into swales or paths will be darker blues, and the wider zones will be fewer flow lines. The static storage allows us to preview and calculate the amount of water being stored on our site. So if we go into top view here, we can see the different zones that we've indicated as basins. And we've done this using closed curves that we've placed on the basins layer underneath the water parent layer. These closed curves are drawn around in plan view areas where we have depressions in our topography, and then that volume is being calculated and added up into the total static storage in cubic feet down here. If we wanted to add another basin, such as indicating that this roadway is a basin for collecting water, we can simply add a closed curve to that layer, and it will automatically include that calculation in and update our cubic feet of static storage. The next selection and preview is the catchments layer, which allows us to see the different sub-watersheds on our site. You can see also that we've provided high points and low points for each of these different zones. Now, each of these zones also has the ability to be connected by pipes. So if we want to connect a layer of watershed to another different layer of watershed, we can do so by putting a curve on the pipes layer with their endpoints inside of each of these zones. By doing so, it's going to recolor those zones to connect them into a single continuous watershed, shown here by this larger darkish bluish green. The catchments layer also includes a change of preview to grid flow, which allows us to see the sub-analysis that is creating the different catchment zones here through this more rectilinear water flow. The way we're calculating this analysis is utilizing what's called an environment. And to create an environment, we need to generate a boundary within which that environment analysis is going to take place. So under our water environment boundary layer, we have drawn a rectangle that encompasses our entire topography in plan view. Within that boundary, we are generating a grid of points using the cell size for that analysis to take place. In this case, a cell size of 1 foot is going to produce a 1 foot by 1 foot grid of points for that analysis, which means that if we lower this value, we're going to have more detail of that analysis. And if we increase that cell size, we're going to have less detail in that analysis. But it's also going to affect the processing speed of that analysis as well. So if you're working on a larger site, it might make sense to have a larger cell size. The last preview option we have in analysis is the volumetric calculation. This allows us to calculate both the curve numbers of our site as well as the total volume of water that is being estimated as runoff on our site. The curve numbers allow you to provide a CN value for how much water is infiltrating based on a series of different conditions on the site. These conditions can be found under the water analysis layers, the HSG soil types, the ground cover type for that particular area on your site, as well as the condition of the soils on your site. Each of these are closed curves that you draw in plan view to indicate which of these zones are which, and then those are combined together with a certain precipitation value based on a specific storm event in order to provide you a calculation for how much total volume is running off. So you can see here we have the ability to preview the different types of layers that we're dealing with on our site. In this case, we have the layers for the different types of CN values, of which there can be many. We also can preview some of the other sublayers. We also have the ability to change the precipitation value input here based on where we are in the United States and using the calculation values from the NOAA's National Weather Service website. So if we were to zoom in and select, let's say, somewhere near New York or Philly, we can see that the values in inches for a 100-year storm at a 24-hour event is 7.77 inches of rain. That's very close to the value that we have input here, which I believe is set for Philly. And so when we insert that value in here and hit refresh, it's going to update our cubic volume runoff values based on that storm event for that amount of rain. One final feature that we wanted to mention in relation to this workflow is its ability to handle both metric and imperial units. So depending on which file template that you open, whether that's the feet or the meters template file that comes with the download of this workflow, this Grasshopper script that you're using for the workflow will work with both of those types, and it will convert all of the units for you automatically to metric. Thank you so much for watching this Topo Workflow video for the updated Topo Workflow. If you're interested in help in relation to LandKit, please visit our website at landkit.design. Additionally, if you're looking for any individual or team training, please check out our campus page to sign up for some training to learn more about how to use LandKit in your offices or on your own time. Thank you.